Community reports say Claude Code costs 9 times more per task than Kimi Code, and OpenCode costs literally zero. That gap compounds fast if you're running dozens of tasks a day. Coding agents are exploding right now, so I'm putting Claude Code, Kimi Code, and OpenCode through 5 head-to-head tests to see who actually earns their keep. The price gap is real, but whether it actually matters for your workflow is what the conditional verdict at the end is for. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. And every number I'm about to share was traced back to official pricing pages and product docs. If you're running 50 plus coding tasks a week, picking the wrong tool could cost you hundreds of dollars a month. All right, test 1, cost. The number that stopped me cold is that Claude Code's max 20x plan runs $200 a month before you factor in per task token burn. And if community reports are right that Claude burns 5.6 times more tokens per task than Kimi Code, a team running 100 tasks a week could be bleeding money every single day without realizing it. Okay, so what I found, Claude Code lists 3 tiers, $17 to $200 a month, which is transparent and easy to plan around. Kimi Code's pricing page shows nothing. I couldn't find a single figure there. OpenCode is free and open source, full stop. The community reported 9x cost gap between Claude and Kimi is worth knowing about. But I want to be clear, that's unverified and not a measured benchmark. So take it with a grain of salt. OpenCode takes cost, and it's not close. Free beats $17 to $200 a month every time on unit economics. And Kimi Code didn't even show up with a published price. I couldn't find one anywhere on their site. OpenCode gets the point, which puts the score at OpenCode 1. Claude Code 0, Kimi Code 0. Test 2, coding benchmark performance. A solo dev shipping a production feature on a deadline needs to know which tool actually writes better code, not just which one talks a big game on its landing page. And benchmark scores like SWE-bench exist for exactly that reason. Iseob, pick a tool that hasn't published any, and you're flying blind on the one thing that matters most. What surprised me here is that none of them publish a single score. Claude Code's page describes capabilities. Kimi Code says it's built for agentic coding. OpenCode claims it tests models but shows nothing. And community reports say Claude follows prompts more carefully than Kimi, getting details right that Kimi misses. But that's user opinion, not a measured benchmark, so I couldn't verify a number for any of the 3. Benchmarks. Nobody wins. All 3 came up empty on official scores, so this one's a tie, which keeps the overall score at OpenCode 1, with 1 test tied across the board. Test 3. Speed. You're onboarding to a new codebase with 200 files, and your agent takes 5 minutes just to map the repo before it writes a single line. That's not a workflow. That's a waiting room. And speed in a coding agent is what separates a tool you reach for constantly from one you dread opening. So what I found, Claude Code claims agentic search that maps entire codebases in seconds, which is a vendor claim, but at least it's a published one. OpenCode runs multi-session parallel agents, which could speed up big tasks, but it's a different mechanism, so you can't compare them directly. Kimi Code has no published speed figures at all, and community reports say Kimi executes faster than Claude, but again, that's unverified. Speed is another tie. Claude's agentic search claim looked like it might give it a clear edge, but without comparable published data from Kimi or a measured test, there's no clean winner to call, and the mechanisms are just too different to score fairly. That brings us to 2 tests tied. OpenCode's still at 1. Okay, so cost, benchmarks, and speed are in the books, but the 2 tests still ahead, context limits and deployment, are the ones that could actually flip your decision, because if Claude Code's platform reach or OpenCode's model flexibility matches your workflow, the cost gap we talked about at the top might not matter at all. Test 4. Context and output limits. The day your coding agent hits a context wall mid-refactor, you lose the whole thread and start over. And that's not just annoying, it can mean an hour of lost work on a complex feature. For a repo with thousands of lines spread across dozens of files, how much the tool can hold in its head at once is a really practical question. So I looked for context window sizes across all 3, and none of them publish a specific token limit on their official pages. What Claude Code does have is support for tens to hundreds of parallel subagents, which is its strongest context feature. OpenCode uses LSP-enabled context loading, which is a different approach entirely, and Kimi Code has nothing published on this dimension at all, so there's just not enough data to score. Context limits? No winner. Claude's subagent architecture looked like it might give it something to work with here, but without a published token limit from any of the three, there's nothing to score against, so it's a tie again. And that's 3 tests tied now. OpenCode still holds its 1 point from cost. Test 5, deployment and modality. You've got a team of 3, 1 on VS Code, 1 on JetBrains, 1 working from a terminal, and you need a coding agent that works for all of them without buying 3 different tools. Platform coverage looks boring on a spec sheet until you're the one stuck without mobile access or Slack integration at the worst possible moment. Okay, so here's what I found. Claude Code has the widest platform coverage by a clear margin. Terminal, web, iOS, Android, GitHub, VS Code, JetBrains, and Slack. OpenCode covers terminal, desktop, IDE, and any editor, and it's model agnostic, meaning you can swap in Claude, GPT, or Gemini freely. Kimi Code offers work, code, and claw modes, but I couldn't find deployment specifics on the official page, so 2 solid options and 1 with real gaps. Deployment is a tie. Claude Code's platform list is genuinely impressive, but OpenCode's model-agnostic flexibility is a different kind of win that's hard to dismiss, so neither one takes a clean point, and that wraps the scoring. OpenCode finishes with 1 point, 4 tests tied, Claude Code and Kimi Code at 0. So where does Claude Code clearly win? Platform reach. Terminal, web, iOS, Android, GitHub, VS Code, JetBrains, Slack, no other tool on this list comes close. Pricing is also transparent, $17 to $200 a month with a clear upgrade path. And agentic search that maps entire code bases in seconds is a real edge when you're onboarding to an unfamiliar repo. Where does Kimi Code win? Community reports say it executes faster than Claude Code on routine tasks and costs roughly 9 times less per task with 5.6 times lower token burn. And those numbers are unverified, but the pattern is consistent across multiple user reports. Kimi K3 can also run inside Claude Code using environment variables, so you get model flexibility without switching harnesses. OpenCode's wins are pretty clear. It's free and open source, no subscription, no per-seat cost, no lock-in, and it's model agnostic, so you can connect Claude, GPT, Gemini, or any provider and swap whenever you want. Multi-session parallel agents and LSP-enabled context loading make it a serious option for power users who want full control over their setup. Okay, so the overall result. This really comes down to what you need, and 9 times the cost per task is the number that anchors the whole decision. If you need the most polished, widely deployed agent with transparent pricing from $17 to $200 a month, Claude Code is your pick. If community speed and cost reports hold up and you can live with no published pricing, Kimi Code. If cost is your hard constraint and model flexibility matters, OpenCode. Free wins on budget, full stop. If the Kimi Code cost story got your attention, check out the video I did on Kimi Code versus Cursor, which digs into whether Kimi's speed and price advantage actually holds up in a real side-by-side, because that comparison gets into the per task numbers in a way this one couldn't.